Here this copper 2 plus is going to be copper plus, and copper 2 plus is plus 2 electron, it is going to be copper. So this is a disproportionation reaction, right? So this is an example of disproportionation reaction where you can know that this is an example of disproportionation reaction. And here you need to find is Faraday's laws, that where that amount of electricity I equal to Q by T, and you need to find out the value of this time, how long did the current flow, right? So Ag plus plus one electron is absent, so it is making metallic silver, and that metallic silver is the reason. So this is a mole reaction. So one to make one to form to produce 1 mole of metallic silver, you need to uh, like 96,500 coulomb is required, right? So 96,655 coulomb is required. So Ag plus plus one electron is going to be Ag silver, metallic silver. Now this is example. So where you have the salt bridge. So reason for the salt bridge is what? So it basically maintain the electrical neutrality of the system, right? Now 3x plus 2y3 plus, and 3x is solid and 2y3 plus aqua. So it is giving 3x2 plus, that is aqua, plus 2y solid. Here E0 cell is greater than 0. Which of the following statements is or correct? So what is oxidation, what is reduction? Show. E0 cell is greater, so this is very spontaneous process, and this is going to be x2 plus and y3 3 plus, that is the tri valent cation is going to be neutral. So this solve is, so basically takes about electron neutrality as well as movement of the electron. So here this y is going to be y3 plus, yes. So remember, so here x is going to be x2 plus, so this is oxidation and this is reduction, right? So y3 plus is a reduction. The reaction at electrode x is an oxidation reaction. Yeah, that's true. Electrode x is going to be oxidation reaction. What is the problem with this? So this is the right. So in both of the cases it is like this. Now so most of the parts are this electrochemistry questions where you understand that in a electrochemical cell, so we'll have cathode and anode, and there will be a reduction at the cathode, and in anode there will be oxidation, right? If you take the mod of this reduction potential value from anode from reduction to oxidation, then you will get a value which is correspond to the positive value, and if E0 is positive, then overall delta G is negative, right? So here, so now this one, the temperature coefficient one need to find. So this daily delta at constant V, you need to find out the temperature, that is the temperature coefficient. And in the temperature coefficient you will that is in the temperature. Now daily delta at constant V, that is at constant daily delta at constant pressure, which is nothing but this delta is by NF. And so daily del T the temperature coefficient, and del T del P, which is just the Here in order to find out a diffusion coefficient, that is d, that is mu RT by Z def, and mu is the what I will say, this is the quantity, and RT by Z def, RT by Z def is, Z is this charge and F is Faraday, so 96,500 coulomb mu RT by Z def. And this is the mobility, just 6.26 into the minus 8 meter square second inverse into volt inverse, and 8.314 jk inverse mole inverse, and 298 Kelvin, so equal to 1 into 96,485 coulomb per mole. So it is coming around 1.6 into minus 9 meter square per second. Is mu RT by Z, this is the value of the charge, and F is the Faraday, and it is coming around 1.6 into 10 to the minus 9 meter square per second. So here, as you know, that this meter square per second and overall basically it is giving this mobility kind of things, and from there you are getting this correct option B, that is 1.6 into 10 to the minus 9 meter square per second. So mu RT by Z mu is 6.26 into the minus 8 meter square second inverse into per volt, and 8.314 joule per Kelvin per mole, 298 K. RT by J10 is 6.26 to the minus 8 meters square per second per volt, and this one is 8.1 joule per mole per Kelvin, and into 298 Kelvin by John into 96,485 coulomb per mole, so equal to 1.6 into the minus 9 meters square per second. So here the electrolyte is placed in a special type of cell known as what kind of cell? This is nothing but this conductance cells. This is called the conductance cells, right? Where you can get the idea about the cell. At 25 degrees, the molar ionic conductivity of Br minus is 7.81 millisecond per meter, millisiemens into meter square per mole. What is the mobility? To find out the value of mobility. So here the mobility is so 8.08 into 0.8 meters square per mole per second, and mobility equal to lambda by f. So f is 96,485 coulomb per c dot p mole inverse per mole. So overall you are getting this mu equal to 8.09 into 10 minus centimeter square per volt per second. So this is the mobility of this of the solution, right? Now in most of the study we have seen that in electrochemistry the cell where you to conduct or you perform the experiment, that is called the conductance cell, and conduction cell, and in the conduction cell you can measure this mobility or ionic mobility of this solution, which is called as millisiemens per meter square per mole. You need to find the diffusion coefficient, that C is the C CO2 minus an ion in aqueous solution at 25 degrees Celsius, and mobility is given already. find out the mobility, that is meter square per volt per second. Now this is the part per potential, so this is equal to what? So this is equal to this meter per second, that is the mobility per potential gradient, right? That is called the so speed per potential gradient, right? Meter into second by volt into meter to the power minus 1, right? So per potential gradient, right? Velocity per potential gradient, so that is called the mobility. And here this ionic conduction is already given for Br minus, so 7.81 millisiemens into meter square into mole inverse, and from there you can get the value of Siemens into meter square into mole inverse, and temperature is 25 degrees Celsius. We need to find the mobility U, right? The relation between molar conductivity and mobility is mu equal to lambda by F. This lambda is called this is the Faraday constant, 96,485 coulomb, and lambda is called this molar ionic conductivity. And if it is a equivalent, so basically you have to divide the value by this by the what I will say, by the charge of the ion, then you will get this molar equivalent conductivity, right? So here mu equal to 7.81 into minus 3 by 96,485. So if you calculate this, mu value is coming around 8.09 into 10 to the minus meter square into whole inverse into second inverse. So this mobility is the, I have already told that this mobility is the velocity per potential gradient, right? So meter into second and per potential gradient by volt into meter to the meter minus 1. So overall meter square volt to the power minus 1 second inverse. So this is called this mobility. Now here we have given already a mobility of an acetate ion in aqueous solution is 4 at 25 degrees Celsius 4.25 into the minus 8 meter, so meter square into second inverse into whole inverse. Calculate the molar ionic conductivity. So you need to calculate the molar ionic conductivity. Right, so mobility is what? Mobility is 4.25 into minus 8 meters square into whole inverse per second. So overall is molar ionic conductivity equal to lambda equal to U into F. F is the Faraday 96,485, and mu is this conductivity, that is the molar conductivity, mobility, right? Mobility into Faraday. So overall you are getting 4.09 into meter millisiemens per meter square into mole inverse, right? So overall, so this is coming the answer A. A is the answer here. Now in most of the case you have noticed that in most of the questions you have noticed that so this is a question where we have talked about the this electrochemical reaction where sodium is going to be reduced, so in oxidation sodium going to be Na plus and water is going to be H2. So H2 is a hydrogen gas, and this is the another where you have AI, that is the aluminium is going to be Al3 plus and Fe2 plus is going to be Fe. And the reaction is possible because the reduction potential of aluminium is more, minus 1.66 volt, than iron minus 0.41 volt. So oxidation of aluminium and reduction of iron will take place. Now coming to here where you have these two half cell potential anode and cathode, and you need to find out the value for this E0. So if E0 is positive, the reaction is spontaneous because delta Z has to be is going to be negative. Now coming to here, so there is a disproportionation reaction where copper 2 plus is reducing to copper plus and copper 2 plus is reducing to again copper. Just if you reverse this first or anything the second one, so if you reverse the first one, then copper plus is going to be copper 2 plus, right? So there that time the potential will be also reversed, right? And for a full equation, you know that this delta G NF overall is equal to N1 F E10 plus N2 F E20, right? is 0.2. That is the standard reduction potential value. So overall this for this half shell reaction the E zero going to be 0.51 volt. So coming to here is nothing but this solid metallic product is going to, so this is a reduction, so it will happen at cathode, right? Reduction into the cathode over at cathode. So here silver ion is going to be deposited to metal, right? So this is very much simple calculation. So you deposit 1.5 gram of silver. So 96,500. So basically, if to get 108 gram of silver, you need to spend 96,500 coulomb, right? Or people used to 95,586 coulomb also, right? So for 1.50, so this is a simple calculation. So this is a simple calculation where you need to find out the value of how much charge is required this coulomb, right? Now Q I equal to QT, right? So from there you can get the idea that how basically how much second is required. 893.525, right? So answer is A, correct option. So here both cathode and anode reaction is going on. So cathode reduction will happen and anode oxidation will happen. And so here this X is going to be X2. So this is the oxidation reaction where IOI3 is going to be the reduction reaction. So it will be occur at anode, right? And here you need to find out the temperature coefficient, which is coming as delta S by NF, daily del T at constant P, but for temperature just you reverse it, so del T daily at constant P pressure, so you are getting delta S by NF, so NF by delta S, right? S by NF. So here again, so you have this mobility. So what is the definition of mobility? So velocity of ion per unit potential gradient, right? So meter into second inverse by volt into meter to the minus 1. So overall it is coming meter square into second inverse volt minus 1. So overall this D is coming as mu RT by ZF. Mu is 6.26 into 10 to the minus 8 meter square into second inverse volt inverse into 8.314 joule Kelvin inverse mole inverse to 298 Kelvin, equal to 1 into 96,485 coulomb per mole, so equal to 1.6 into 10 to the minus 9 meter square into second inverse. So overall it is coming around the value of 1.6 into 10 to the power minus 9, right? So answer is B. So in most of the questions you have seen that now this is the conduct. Now you have to find out the molar ionic conductivity is already given is for bromide Br minus, so it is coming around 7.81 millisiemens per meter square per mole. So what is the mobility? So here this mobility is given 7.81 minus 3 by 96,485. Right. So what is given molar conductivity and equivalent conductivity? Equivalent conductivity is equal to molar conductivity by the X or G. G is the charge of that ion, and if you divide this molar conductivity by charge of the ion, so it will be the equivalent conductivity, right? So for monoionic species, molar conductivity and equivalent conductivity is same, but for the bianic species or bianion like anion species, so for that you need to multiply the equivalent conduction by the charge of that multiple into 2, that is because this is a bivalent cation. So and as a result you will get the value of this around 2 into equivalent like equivalent conduction equal to molar conductance, right? So similarly, so if you see that this is the last question where you need to find out the mobility of acetate ion in aqueous solution is already given. Calculate the molar ionic conductivity of the solution. So it's coming around 4.09 millisiemens per meter square per mole, right? So in most of the question you have understood that electro in electrochemistry you need to understand the formula for this, why this one any electrochemical reaction is going to be happen positively or negatively, or that means it may not happen or it may happen. If for making it to be happen, it delta G has to be negative, that is the potential has to be positive, right? And for the another case, for the another case, so you need to find out this how much electric, so Faraday's law you need to apply. From here you can get how much time is required and how much charge is required to make any specific product. So this is a reduction where metallic silver will be formed from metal ion, so silver will be formed from Ag plus. So this is a disproportionate reaction where copper 2 plus is going to be in first one case oxidation then reduction. But if you change the reaction scheme, like if you reverse, then accordingly this potential will be also changed, and corresponding this energy corresponding the spontaneity will be also changed. And here is also the same case and this one. So thank you everyone for the attendance. We will meet on this and a special session on 19th tomorrow, and we will go to some more questions. Thank you.